This is problem 33 from the Open STAX chemistry textbook. For this problem, you'll need your calculator and a periodic table. So we have some information here. We want to know the moles of this gas, so we don't know what the moles is, okay? As we keep reading, we are given the volume. The volume is 4.3410. Quite a few sig figs there, and that's in units of liters. The temperature, how unusual, is given to us in actually the Kelvin we need, so 788.0 Kelvin, okay? And the pressure is equal to 1.220 atmospheres, okay? So that's the first problem. Now, you don't see two volumes or two temperatures or two pressures, so we don't need to use one of the formulas where you have the V1, V2, T1, T2, P2, P1, P2. What you do need to use is the ideal gas law, okay? So PV is equal to nRT, and remember that R has units of liters, atmospheres, moles, and Kelvin, which is exactly what we have here already, so we don't have to do too much busy work. Now, to solve for n, we want to divide both sides of this equation by r and t. So r cancels and t cancels, and that gives us a new formula. N is equal to PV over RT. And here we just want to essentially just plug things in. So the pressure is 1.220 atmospheres. The volume is 4.3410 liters. R is a constant that should be supplied to you. And very importantly, the units are also supplied to you, and that's what you can use to make sure your pressures, temperatures, and volumes are all in the correct units. And we don't want to forget temperature. That's 788.0 Kelvin. For purposes of personal satisfaction, let's make sure that the atmospheres cancel, the liters cancel, and Kelvin divided by Kelvin is cancel. So we're left with moles. Okay, 1 over moles. And so let's grab our calculator now and calculate this out. Okay. It's a bunch of numbers here that you've got to punch in carefully. And if you do this correctly, you should get 0.08. Let's see, we want this to be maybe 4 significant figures. 8186. Okay, I'm going to double check this. As I recommend all students. Okay. 0.0. Okay, so that's good. Now, this is not just some random chemical. This is BF₃, boron trifluoride. Okay, so that's what we have going for us right now. Now, to answer this second question, we need to convert the moles to grams. Okay, grams of BF₃, and we do that using the periodic table. So boron, if you look, has a number of 10.81, and fluorine is 18.998. So we're going to take the 18.998 and multiply it by 3, right? And then we're going to add that to the 10.81, and we get a value of 67.804. What does that number mean? It means that 1 mole of BF₃ has a mass, or a molar mass, of 67.804 grams, okay? And we're going to use that as a conversion factor up ahead. So we start with our moles, okay? And we set up a nice fraction, which is our conversion factor. And we want the 1 mole of BF₃ to be on the bottom, so that moles of BF₃ cancels, right? And up on top is going to be the 67.804 grams, all right? And so let's do this math now on our calculator. And I would recommend double checking this, but I get 5.550 grams. Okay, And I'm going to write the chemical formula after the grams so we can be sure to recognize that as that chemical. So that's how you do this problem. Thanks for watching, and please consider subscribing to my channel to support me. Have a great day.